RSA encryption tutorial. The RSA is a lot more basic than the DES system that we went through previously. This will be a very short video in terms of being able to teach you how to encrypt the RSA way. Make sure you remember all of the formulas that we will be using. I would suggest writing them down, as once again, like all the other videos, you will be tested at the end. So let's begin. So RSA is an encryption method that uses both public and private keys. So the private key is only known by the person who actually created the key. So no one else knows it, whereas the public key can be distributed anyway. So whereas the public key, anyone can know it, it doesn't matter if they do. The private key, the only person who knows what it is the person who actually created it. The idea of it is that if the public key is known by a person, they still can't decrypt the message because they don't know what the private key is. So even if they have the public key, it doesn't matter. Without the private key, they can't do anything. So let's say we have Alex, and he's sending a message to George. George needs to create a number of keys, and he uses these different methods. The first method is the modulus, where it chooses a prime, which we'll call P, and another prime Q, and then he calculates n equals PQ. So P multiplied with Q equals n. Once he does this, he figures out the Euler's tightened function, which, as you can see here, it calculates tightened function with P minus 1 times Q minus 1. So, and that will equal your tightened function. We take this then to create Alex's public key, where your E value is prime to your tightened function. Now I know this may sound very confusing, but really once you get into it, it is very easy, trust me. Also the E value is given to you, so you don't have to worry about acquiring that. The E value is prime to the tightened function. And then after that you have to create George's private key. So a D value such that E multiplied with D modulus the tightened function equals 1. Now if you don't understand what mod is, that's no problem, because they are on calculators. There are mod calculators on the internet. I would suggest using Wolfram Alpha. And so you don't really need to understand how mod works, but if you wish to look up on it, you can. But in a test situation, you are tended to be given calculators in a situation where you can figure out what the modulus is. So you shouldn't really need to worry about how it works. As long as you have a calculator in your possession, it shouldn't be an issue. So we're going to go into the encryption and decryption process. So let's start with the encryption process. So let's say our prime is P equals 61, Q equals 53, and E equals 17. It's now time to go through the 4 stages that we mentioned previously. So step 1, PQ equals N. We have to figure that out. So P equals 61 and Q equals 53. So we just figure out 61 times 53. Once again, if you want to use a calculator, feel free. Calculators would be supplied in this test situation anyway. And this equals 3,233. So now we figured out N, we go on to the tightened function, which is P minus 1 times Q minus 1. So that's basically 61 minus 1 times 53 minus 1. So that's 60 times 52. And once again, if you wish to use a calculator, this equals 3,120. So we have our Euler's tightened function. Then the next stage is usually figuring out E, but we already know that E is 17. There is another stage to figuring out what E is, but usually E is supplied to you in a test situation. So we will not need to worry about that for now. And then we go on to the 4th stage, where E multiplied with D modulus the tightened function must equal 1. So we have to figure out D using this. Now, I used Wolfram Alpha, which is online. It's a calculator that calculates all of this for you. So what we do, we put E in, which is 17, times D, mod N, mod the type function, which is 3120. Now if you put this in Wolfram Alpha online, it will give you the answer that D equals 2753. Which is why I said I don't really need to tell you how moduluses work, because with calculators you don't really need to know, because calculators would be supplied in a test situation anyway. So now with this information we can encrypt the message, and we must use the formula C equals M to the power of E mod N. So let's say we're trying to encrypt the message 123. We use this formula, which is global. This is used throughout the whole of RSA, and the keys that we just generate to encrypt it. So we already know that E is 17. We've got our public key, we have our private key. So let's move on. So C equals M to the power of E mod N equals 123, our message, to the power of 17, which is E, mod N, which is mod 3233. Once again, I used the Wolfram Alpha calculator online, and this came up with 855, which means that we have encrypted our message 123, used RSA encryption and encrypted it, and is now 855 in ciphertext. And that's it. It is as easy as that. Now, to decrypt it, once again, it's very basic. We are given a formula, and the formula to decrypt the message is M equals C to the power of D mod N. And we already know all of these things, so we just once again need to do the math. So we know that C is 855, our ciphertext. We know that D is 2753, so 855 to the power of 2753. Mod N, so we know that N is 3233, so mod 3233. Once again, use a calculator, because you wouldn't be able to figure this out otherwise, and we get our original message back, 123. So it is literally as easy as that. As long as you have a calculator with you, which is essential for RSA, it is very unlikely you would be tested on RSA without the calculator. As long as you have the calculator with you, it is very basic. And for the test and for the multi-choice test in the project, you will be supplied with a calculator, probably Wolfram Alpha. So I'll be watching your progress, and Wolfram Alpha will be available to you. As long as you don't go on any of the websites, it's no problem. Okay guys, now it's your turn. Basically, I want to use the RSA encryption method that we just went through to find the ciphertext. It's either one of the four answers given here: A14, B11, C17, or D13. So our primes are different: P equals 11 and Q equals 3. Our public key E equals 3, and the message we are trying to encrypt is 7. I want you to figure out what the ciphertext will be. Good luck.